Hello again, everyone. We are finishing section 7.3, and today we're going to talk about infinite geometric sequences and finding their sum. So the difference between a regular geometric sequence and an infinite one is that infinite one is never going to end. We have our formula. We have the infinity symbol, so we know it's an infinite geometric sequence. It's something that's going to continue on and on and on and on and on and on and on forever. A sub 1 is still our first term. And R is still our common ratio. The biggest part to this whole thing is that we have to check that our common ratio is less than 1. That's a must. If our common ratio is not less than 1, then it will not have a sum. It's not possible to do it because that means the number is going to grow, and it won't come to a specific value. This is kind of an introduction to what's called limits if you're moving on in math. So every time that we check our R, get my highlighter back here, we have to make sure that our R is less than 1. If it's not less than 1, then we're in this situation and we say that it will not have a sum. So let's try. We have an infinite geometric series, 1 plus a third plus a ninth plus a 27th, and so on. We know that 1 is our first term. And then we need to figure out what our common ratio is, or R. Remember, in order to do that, we can pick any two terms we want and divide the one on the right by the one on the left. So 1/3 divided by 1 is a third. Before we move on, we have to check, is the absolute value of positive 1/3 less than 1? And it is. Well, absolute value of 1/3 is a third. Is 1/3 less than 1 whole? It is. So because of that, we're allowed to use our formula. I'll write it up here again. We have a sub 1 over 1 minus r. So the sum of our infinite sequence, 1 divided by 1 minus 1/3. Again, if you put this into the calculator all at one time, you have to put an extra set of parentheses around this bottom so that the calculator does the subtraction before it divides. And you'll probably end up with a decimal. So make sure you use your math enter to change that decimal into a fraction. And we should get our infinite sum to be 3/2. All right, for the second example, we have a sub 1 is 4. We need to find our common ratio, R. And again, pick any two values you want. So I'm just going to pick these first two. 4/5 divided by 4. If you're typing that into the calculator, remember that you want to put that 4/5 in parentheses. And then change that from your decimal of 0.2 into a fraction. Math enter. And we end up with an R value of 1/5. So again, we have to do our check. Is the absolute value of 1/5 less than 1? The absolute value of 1/5 is positive 1/5. Is 1/5 less than 1? Yes. So we're good to go. We have the sum of our infinite series. A sub 1 is 4. 1 minus 1/5. Again, if you're putting this into the calculator all at one time, fractions always go in parentheses, and then we need to make sure that that subtraction on the bottom also goes in parentheses. Type that in, and we end up with 5. So no matter what we do with all of those values, if we keep multiplying by a fifth, by a fifth, by a fifth, then that sum is just going to be super close to 5. Always, always, always. And that very simply is infinite geometric series, finding that sum. Hope you've enjoyed your sequences and series unit, and we'll see you soon.